Hi, thanks for joining me. Today I've got a problem from the 2022 MAT. So this is the Maths Admissions Test for the University of Oxford. We're starting off with a fact here. We're told that for all real numbers n, it is the case that n to the 4 plus 1 equals n squared plus root 2n plus 1 times n squared minus root 2n plus 1. And from this fact, we may deduce that n to the 4 plus 4 is never a prime for any positive whole number n, a prime number for exactly one positive number n, and so on, but for 2, 3, 4 positive whole numbers n. So in other words, how many positive integers n is it such that n to the 4 plus 4 is prime? Now I encourage you to pause the video and have a go at this, because I actually struggled with this initially, but there's a really nice trick to this problem, so I'll dive into a solution now for it. What we're going to do is we're going to say let n equal, let's go capital N divided by root 2 here. So we're going to use this fact here, and this is true for all real numbers n, not just integers, so all real numbers. And so I'm just going to replace n with capital N over root 2, and capital N is going to be our integer, which I'll put here. So this thing here, if I sub in little n is capital N over root 2, on the left hand side, n to the 4 plus 4 is capital N to the 4 divided by root 2 to the 4, which is 4. And then plus 1 equals little n squared is going to be capital N squared over 2, plus root 2 little n is just capital N, and then plus 1, all times n squared over 2 minus n plus 1. Now all I'm going to do here is multiply both sides by 4, and in doing so my left hand side becomes n to the 4 plus 4, which is what we're interested in. And what I'm going to do is multiply each of these brackets here by 2. So this first one will be n squared minus 2n plus 2, and this second bracket here will be n squared minus 2n plus 2, like so. And now we want n to the 4 plus 4 to be prime. But we can see that each of these brackets here are clearly integers, and in fact it's not too difficult to see, oh sorry, that's supposed to be a plus 2 in there. It's not too difficult to see that in fact they're both positive integers. And so if we want this thing to be prime, one of these brackets has to be 1. And so therefore the smaller one, which is clearly this guy, must be 1. And so if I just squeeze this on here, we can get that. And subtracting 1 from both sides, we get that. And now this is a perfect square. This is n minus 1 squared. And so if n minus 1 squared is 0, that must mean that n is 1. So the only possible way that n to the 4, capital N to the 4 plus 1 is prime, is if capital N equals 1. N to the 4 plus 4, sorry, is if capital N equals 1, and if we just sub that in, we get 1 to the 4 plus 4, which is 5, and that is prime. And so therefore there is precisely one positive integer n for which n to the 4 plus 4 is prime, and that is when n is 1. So a pretty nice problem. I think it's quite tricky to see how we want to turn this 1 here to a 4, and the trick is by doing this substitution here, but really not obvious. But I guess when we see that there are root 2's in this here, that's a small indicator that it's got something to do with the square root of 2. Anyway, if you have enjoyed this video, please do give it a thumbs up, and if you're new to the channel, please do subscribe if you haven't already. Thanks so much for watching. I'll catch you in the next one. Have a great day.